Hey everyone. So you should have the packet that the sub gave you, and I just want to go through a couple of the problems. There, we did one yesterday in class, so this should look sort of familiar. So let's start with number one. So the idea here is we're trying to solve this for y, essentially. Sometimes we'll be able to solve it for y, sometimes it'll be like y squared, and we'll kind of leave it a little less simplified. But our goal here, so we're given a differential equation, dy dx, so the slope is equal to 2x over y, right? So the strategy we're going to use is to try to get all the x stuff on one side and all the y stuff on the other. So we kind of cross multiply here, right? And we're going to end up with y dy equals 2x dx. Okay. And then we'll take the integral of both sides. So I'm going to write the integral of y dy equals the integral of 2x dx. And by doing that, I'm going to get rid of dy and dx, so I'll just have an equation that has y's and x's. Alright, so the integral of y dy is y squared over 2 plus c, and that's going to equal 2x squared over 2, which is just x squared, plus c. Okay, now, they're not the same constants, so once we have two different constants, we have to call them c1 and c2. Okay. And what I'll do here, so I've got x squared, or y squared and x squared. Typically, we'll leave it. I'm not going to solve by like square rooting or anything, so what I'll do is I'll get the x squared and the y squared on the same side. So I'm going to subtract x squared from both sides, and we'll end up with y squared over 2 minus x squared. And the other thing I'll do is I'll subtract the constant to the other side, and we'll just call it c3. So that's my solution. It's y squared over 2 minus x squared equals a constant. Okay. If we gave you an initial condition, like x is 3 and y is 5, we could plug those in and solve for what the constant is. But I didn't give you an initial condition, so we're just finding the general solution, which has this c in it. Okay. Number 2, main difference here is that it's not written in dy dx form. We're going to switch it to that to make it easier. So we're going to change this to dy dx, and I'll subtract the x to the other side in the same step here. So 4x squared minus 3x. Now I'm going to separate my variables, so I'm going to have y's on the left and x's on the right. All I need to do is bring the dx over. So now my problem is going to be dy equals 4x squared minus 3x dx. And here's where we take the integral of both sides. So I take that integral, and now, like we talked about yesterday, integral of dy is y plus c, but like what you'll notice is every single time here, it's a constant on both sides. We don't have to write it on both sides. We can just keep it on one side. So I'm going to write y equals, I'll do the constant on the right side. 4x squared, so that's going to be 4x cubed over 3 minus, this will be 3x squared over 2 plus c. I've got it solved for y. Because I didn't use any other c's, I don't need to call it c1 or anything. I can just call it c. And there's my general solution. Let's do one more here. dy dx equals x plus 3. I can just separate the variables right away. dy equals x plus 3 dx. And now I'm ready to take the integral of both sides to get rid of the dy and the dx. And I'll get y equals x squared over 2 plus 3x plus c. So most of these problems are either like number 2 and 3, where the separation of variables is really just get all the x's on the right side, or number 1, where we had to get the y on the left and the x on the right, okay, and we ended up with an x squared and a y squared. Okay, so for the rest of class, I want you to finish the packet. So if you look on the next page here, all the rest of these problems are similar. Number 8, put a little star next to. That's more of a challenge problem. So I want you to try it out and see what you can get to. And then the homework is to do those last 3 or 4 practice problems on the very last page. Okay, I posted the solution key, so as you work on that, you can check your answers, and have a good weekend.